Hello, welcome. This is Unit 2, Exponents and Radicals. This particular question is about how to simplify radicals. And so I just want to do a quick review of some of the concepts we need to understand. One is that if you have the square root of a number, let's go ahead and call this number the product of a times b, that's the same as the product of a times the product of b. So you can have the square root of a product or the product of the two factors of that same product. And the other thing that would be useful is to recognize maybe some of the perfect squares. 1 squared is 1, 2 squared is 4, 3 squared, 9, then we go 16, 25, 36, 49, 64, 81, 100, and so on. Well, we could go continue, but that's enough. I think we get us started here. So one way to do this, I'm going to show you a couple ways. One that's kind of really dependable, but maybe a little bit longer. And the other one that's a little bit faster, but it really depends on how well you know your times tables and if you can recognize these perfect squares that I just talked about. So one way to do this is to kind of break down 24 into its prime factors. Once again, the prime numbers, we'll just call them primes. We only need a few for this particular problem, but they are numbers that have exactly two factors. So they start with the number 2. Then we've got, it's the only even prime number. Then 2, then 3, 5, 7, and then 11, 13, and we could continue, but that's enough again for right now. That's fine. So we want to break 24 into its prime factors. And so I'd say, let's look at 24, and I'd say 2. I want to check to see if it can divide by 2, and 24 is even. So yes, 2 goes into 24 12 times, and then 2 will go into 12 still, because 12 is still even, 6 times, and then 2 goes into 6 3 times. Now 3 is no longer even, but it also is prime. It's in that list of primes. And so 3 goes into itself 1 time. And when you get to 1, you're done. And so the prime factors then are right here. 2 times 2 is 4, times 2 times 2 is 4, times 2 is 8, and 8 times 3 is 24. And you can do that in any order that you want, but those are the prime factors of 24. So then I can rewrite this whole expression, the square root of 24, the square root of 24m to the 5th power as the square root of 2 times 2 times 2 times 3 times, and you don't have to write this out, but I think it's helpful to see, m to the 5th power is m times m times m times m times m. And one of the things to think about it with a square root is that it's called a square root. Let's say the square root of, let's say, 9 is 3, because it's the kind of the opposite operation of squaring. This is true precisely because 3 squared equals 9. And so the square root, all of the radicals have an index. When the index isn't written, it's understood to be 2. There's like an invisible 2 there. And so we're going to go back here and say, all right, well, you could kind of make an analogy that a square root with index of 2 is kind of like a level 2 security prison, and you can escape from that prison only if you have 2 inmates working together. So there's a pair of 2s right there, and they're going to get out as a 2. And then I only have 1, 2, and 1, 3, so those stay in. There's a pair of m, so that's going to come out. There's another pair of m, so that's going to come out also as an m. And then there's another m that doesn't have a pair that's going to stay inside. And so these ones right here that I'm kind of darkening here, those stay under the radical. They just get multiplied back together. So instead of 2 and 3, that will be 6, and then with the m, 6m. So what I end up with, everything just kind of gets multiplied back together. 2 times m is 2m squared times 6m. And so these two 2's here became this 2 right here, which is again that 2. And this 2 and 3 and this m get multiplied back together. That's the 6m. And then finally, we've got this m, this pair of m's and this pair of m's come out. Here's that m and that m times m, which is this m squared. And so that's how you could do this kind of in a fast way, or sorry, in a very dependable way. But in a little faster way is to recognize, at least with the numbers, if any of these are if any of these perfect squares here are factors of 24, and the only one that I can really see there that would go into 24 would be 4 itself. And so I could rewrite the square root of 24 as the square root of 4 times the square root of 6, because 6 times 4 is 24. And then with the m squared, or m to the 5th, I've got the square root of m to the 4th times the square root of m. And the square root of 4 is 2. The square root of m to the 4th is m squared, because m squared times m squared is m to the 4th. And then these two, the square root of 6 and the square root of m, just stay under the radical as the square root of 6m. That may not be easier for you, but you can definitely do whichever way works for you that you like best. This might be more reliable, but that's how this works. Study hard. If you have questions, you need help, please don't hesitate to ask. We're all here to help you.